Hello everyone. In this video, we're going to explore the graphs of inverse sine and cosine function and their transformation. Alright, first we need to recall about the order of transformation. Y equals A times F times B times S minus S plus K, right? And the order should be B, H, A, K, right? Now, let's take a look at the first one right here. Below is the graph of the function f of s equals sine s, where s from negative pi over 2 to pi over 2, right? And this is actually the domain of this function, right? So you need to write domain here. Alright, now question 1, label the coordinates of the point A and B on the graph, right? So point A right here is going to be negative pi over 2, right? We got it right here, negative pi over 2. And it's actually negative pi over 2, right? Remember, pi is going to be 3.14, right? So 3.14 divided by 2, approximately 1.57, right? So it's going to be right here. And the y value should be negative 1 right here, right? So negative 1. And this one is going to be pi over 2 and 1, right? So we see that the domain should be negative pi over 2 to pi over 2, right? The range should be negative 1 to 1, right? So we need to write over here. Range negative 1, comma 1, right? Alright. Now, sketch a graph of the function inverse sine of s on the same axis, right? So we just grab s and y value, right? So the point negative pi over 2, comma negative 1 becomes negative 1 and negative pi over 2, right? So it's going to be right here. It should be right here, right? And this guy becomes 1 pi over 2, right? So it could be right here. Alright, now we sketch this one. It's going to be something like this. Question number 3. What are the domain and range of the f of inverse sine function? Right, so we just grab the domain and range right here, right? Domain becomes range, right? So it's going to be negative pi over 2 and pi over 2, right? And the domain should be negative 1 and 1, right? Now, question number 4. Does the graph of f inverse of s equals sine inverse of s have any symmetries? Yes, it has a symmetry right here, right? About the origin, right? Alright, what kind of the function f inverse of s equals sine inverse of s? Alright, this is the odd function, right? Because it's symmetrical about the origin, right? Now recall the sine function is odd. So sine of negative s equals negative sine of s. The cosine function is even, so cosine of negative s is cosine of s, right? So this one is odd, this one is even. Keep that in mind. Now the sine inverse is odd, right? So sine inverse and the original sine function, they both odd function, right? What equation can we write relating to sine inverse of s and sine inverse of negative s? The sine inverse function right here is odd, right? So we just write sine inverse of negative s equals negative sine inverse of s. Alright, keep that in mind. This formula is extremely important. Alright, now question number 5. We're going to use this formula to calculate the following, right? So, sine inverse of negative root 3 over 2 is the same thing as negative sine of root 3 over 2, right? I just use the formula right here. Alright, so it's gonna be negative sine root 3 over 2, we got it right here. It's gonna be pi over 3. So this guy equals negative pi over 3. Right? Now question B. Sine inverse of negative 2/3 is the same thing as negative sine of 2/3, right? And then this guy is the same thing as negative of what right here? 0.729, right? Now question C. Sine inverse of this one is the same thing as sine inverse of. Now I look at this one, I see that root 6 minus root 2. This guy is root 2 minus root 6. So if I factor negative 1 out, it turns out to be root 6 minus root 2, right? Over 4, right? So then I apply the formula right here. So it turns out to be negative sine inverse of root 6 minus root 2 over 4. Alright, but this guy equals pi over 12. So this guy equals negative pi over 12, right? Now, one more question about this one. For example, we need to calculate question D right here. Arc sine of negative root 2 over 2. Alright, so we look at the unit circle. Alright, arc sine of negative root 2 over 2, we look at the first and the fourth quadrant right here, because this is the range of the sine inverse function, right? So this one is pi over 4, right? Which means root 2 over 2 and root 2 over 2, right? And then this one is 7 pi over 4, right? It's gonna be root 2 over 2 and negative root 2 over 2, right? Now, outside we look for the y values, right? So the y value is gonna be right here. Alright, so the angle right here actually 7 pi over 4. Now, if we put this guy equals 7 pi over 4, this is totally wrong, right? You need to get rid of this mistake. Why? Because 7 pi over 4 is outside the range. Remember, the range for the sine inverse function is going to be negative pi over 2 and pi over 2. We got it right here. It's right here. Alright. It should be the bracket. Alright. Now, how do we know that? We just take pi approximately 3.14, right? 3.14 times 7 is going to be approximately 21 point something. And you divide by 4, it's going to be 5 point something. 5 point something is outside this one, right? Because this one, if you convert it to decimal, it's going to be 3.14 divided by 2. It's going to be 1.57, right? So it's negative 1.57, comma 1.57, right? So this guy equals 5 point something, right? So this is outside this range. So this is not the answer, right? So we need to find a replacement for this one, right? We have two different ways to find a replacement for this one, right? If we go counterclockwise, right, it's actually 7 pi over 4, right? We need to use the reference angle right here, right? So we need to take 7 pi over 4. We subtract 2 pi, right? So it turns out to be negative pi over 4. So the answer must be negative pi over 4 right here. Alright. The second way, we just go clockwise. If we go clockwise, this is actually negative pi over 4. So we immediately have the answer right here, right? We don't need to use the reference angle, right? So keep that in mind, all right? Don't make this mistake. This is not the answer, okay? The answer must be negative pi over 4 because negative pi over 4 is inside the range right here. Now let's move on to the problem number 2. The graph of the function cosine of s is given right here. The domain is going to be 0 to pi, right? So now question number 1. Label the coordinates of points A, B, and C, right? Point A right here is going to be 0, 1, right? So very simple. Now point C right here is going to be, this is 3.14, right? So this is actually pi and negative 1, right? Negative 1. Now, this is the midpoint, right? So we just take pi as 0 and divide by 2. So this is actually pi over 2, right? And then this one should be 0, right? Now, sketch the graph of f inverse cosine of s, right? So we just grab the coordinate of points A, B, and C, right? So 0, 1 becomes 1, 0, right? So it's going to be right here. Pi over 2, 0 becomes 0 pi over 2. So it's going to be right here. Pi negative 1 becomes negative 1 pi, right? So it's going to be right here. Alright, now we just connect them and we get the graph, right? Now, question number 3. What are the domain and range of the f inverse of inverse cosine function? Alright, so we just grab this one right here. We have the domain right here and the range should be negative 1 to 1, right? So this one should be negative 1 to 1. Now we just grab this one, domain should be negative 1 to 1. And the range should be 0 to pi, right? Now question number 4. Is f inverse of s equals cosine inverse of s an odd, even, or neither, right? We look at this one. The function inverse cosine of s does not reflect over the origin, right? Does not reflect over the y-axis, right? So it's neither, right? Now we review this one. The sine function is odd. The inverse sine function is also odd, right? The cosine function is even. The inverse cosine function is neither. Not even, not odd. So keep that in mind. Now let's move on to the problem number 3. The graph of the f inverse of s equals inverse cosine of s and g of s equals cosine inverse of negative s as shown, right? Now question number 1. Explain how the graph of g of s equals inverse cosine of negative s, which is this one right here, can be obtained from the graph of f inverse of s equals inverse cosine of s, which is this one right here, using horizontal transformation, which means the things related to the input, right? So anything inside parentheses, right? So we look at this one right here. We see that the difference between this guy and this guy is the negative sign inside parentheses, right? And in front of s. So this actually reflects over the y-axis, right? So if you reflect over the y-axis, I copy this one over here. It's actually right here, right? So we just say this reflect over the y-axis. Alright, question number 2. Explain how the graph of g of s equals inverse cosine of negative s can be obtained from the graph of f of inverse of s equals inverse cosine of s using the vertical transformation, which means the thing related to the output, right? Look at this one right here. Now, I'm gonna reflect the original function over the x-axis, right? Alright, I know that the intersection right here should be negative pi over 2. This one right here should be pi over 2. Now I translate this one up pi unit to get the rest one right here. So I add pi, right? The first one I reflect the original function over the x-axis, and then I translate up pi units, right? Alright, now using the vertical transformation from number 2, how could you write the function g of s in terms of cosine inverse of s rather than g of s equals cosine inverse of negative s? So you just write g of s equals negative cosine inverse of s plus pi, right? Or you can write pi minus cosine inverse of s, right? Now go ahead, use Desmos to demonstrate this situation, right? So I have the inverse cosine of s right here. Now I need to multiply the output by -1, right? So I get this one right here. Alright, it reflects over the x-axis, right? Now I'm gonna translate this one up pi units, right? So it's gonna be like this. I get this one right here. Now I use different colors so that you can see it. Alright, so I delete this one, right? It's gonna be the blue one right here. So the blue one is actually this function right here. Alright. The blue one and the green one, they both the same. Alright, so keep that in mind. Now let's move on to question 4. Using your equation from number 3 right here, we need to calculate the following, right? So we know that g of s equals cosine inverse of negative s, right? And g of s also equal this one, right? So I can write cosine inverse of negative s equal this one, right? This is the formula I need to use to calculate the following, right? Keep in mind, right? So, oh, I forgot negative sign right here. Now, cosine inverse of -1/2, I apply the formula right here. It's gonna be pi minus, right, cosine inverse of 1/2, right? Right, by using the formula right here. Now, this one is the same thing as pi minus cosine inverse of 1/2 is going to be pi over 3 right here. Right, I substitute over here. Alright, now I simplify. It's going to be 2 pi over 3, right? Now, for this one right here, I need to manipulate a little bit, right? So I need to factor the negative side out, right? So I have cosine inverse of parentheses. I put the negative side in front of the fraction, right? So this guy turns out to be root 6 plus root 2 over 4, right? Now in this situation, s should be root 6 plus root 2 over 4, right? So I can apply the formula right here. It's going to be pi minus cosine inverse of root 6 plus root 2 over 4, right? Now it's going to be pi minus, this guy is the same thing as pi over 12 right here, right? So I put pi over 12, and then I simplify, it's going to be 11 pi over 12, right? This is the answer. Alright, let's move on to question number 5. Rewrite the value of cosine inverse of -3 over 4 in terms of inverse cosine of a positive input, right? So I just write over here cosine inverse of -3 over 4 is the same thing as, I'm going to use the formula right here. It's going to be pi minus cosine inverse of 3/4, right? And that's it. Now, question number 6. Find the exact value of cosine inverse of phi, right? Now look at this one. Phi in this situation is the input of the inverse cosine, right? We look for the domain of the inverse cosine right here. Because phi is the input, right? So the domain is going to be right here. -1 to 1 only, right? We have number of phi right here is greater than 1, right? So this one is undefined. Keep that in mind when you work on the inverse trigonometry function. You need to check for the domain carefully, right? Now question B. Cosine inverse of cosine phi pi/3, right? In this situation, phi pi/3 is the domain of the cosine function, right? We know that the domain of the cosine function is going to be 0 to pi, right? Now, since phi pi/3 is outside of this domain, right? So, because it's outside of this domain, we need to use the unit circle to find a replacement for this one, right? So, we have pi/3 right here. This is 2 pi/3. This is 3 pi/3. And this is 4 pi/3. And this is 5 pi/3 right here. Cosine function represent the x-axis, right? So this guy and this guy have the same cosine value right here, right? So instead of cosine of 5 pi/3, I just write cosine of pi/3, right? So, and then the answer should be pi/3. Right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.